Hi guys, welcome to this tutorial and I am your host and your instructor for today, Stunner K. Due to demands and by some noun friends, I was beckoned on to do a tutorial for them. Because of the situation we are in right now, COVID-19 and coronavirus everywhere is totally locked down. So everything's going virtual these days. So I thought to myself, okay, instead of making it for one person, why not just make it for a lot of people? And that's why we have this right now. So I'm gonna be doing this over time, like a tutorial, virtual tutorial, and we shall be commencing with MTH101. We'll be talking about set theory, basic set operations, set of numbers. That's module 1. So let's just get right into it. Meanwhile, we are using the nouns material, National Open University Math 101 material. So please, if you don't have a soft copy, go down to the website, go down to courseware, download the material. It's free of charge. But if you have the hard copy, maybe you have collected from school, you can also use that to go a long way so we can follow up and be on the same page while I'm running this series of tutorials. Now, a set is a list of objects, or we could say a set is any well-defined list of objects. But it's not only that, a set could also be a collection of objects or a class of objects. So we can just concatenate or coin them together or gather them together into one definition and say a set is any well-defined list of objects, or a set is any well-defined list, collection, or class of objects. So any list of objects cannot just be considered as a set, it must be well-defined. Same also, any collection of objects cannot just be called a set, it has to be what? Well-defined, as well as a class also. So if I give an example, like a list of objects, we say a chair, a table, a sofa, a TV. Now all these are lists of objects. I can say 1, 2, 3, 4, 5. I can say Ayo, Ken, Bayo, Jafet. This is also a list. But can we consider them as a set? Remember the definition. We said a set is a list of objects, a collection of objects, or a class of objects. Now there are conditions that would make any list a set. One is it must be well defined. So I could say for this is a set of integers between 1 and 5, right? This is a set. Now it's well defined. I can say this is a set of items in a living room. It's well defined. I can say this is a set of males in now. It's also what? Is well defined. Now we can consider them as what? As a set. Now a set could also be in the form of an equation, a quadratic equation. So I can say A is equal to x squared plus 2x plus 1 is equals to 0. This could also be considered as a set, whereby the solution of this quadratic equation is the element of the set. Now let's go simpler. If I say A is equal to 2, 4, 6, 8, you will agree with me that these are even numbers, right? 2, 4, 6, 8. This is the set. And we are saying set A. If you look at it, I didn't say small letter A is equal to 2, 4, 6, 8. A set must always have what? A capital letter. It must always be denoted by a capital letter. So this is wrong. This is correct. Now the elements in a set must always be separated by commas. Now imagine I had said A is equal to 2, 4, 6, 8. This is actually 2,468 and not exactly 2, 4, 6, 8. Are we getting it? One of the characteristics of a set is that a set is denoted by a capital letter, and also a set, the elements in a set are separated by commas. The third one is a set is usually in a bracket. This is a bracket. You can call it braces. Some people call it coily brackets. You know, we have the other parentheses like this, bracket like this. This is, I don't know if I'm drawing it right, but let me try and get it right. You know, it's good to get it right. It's something like this. Yeah. As regards to the brackets that we know. Now this is used for a set where the elements are inside these brackets separated by commas. We actually don't use this kind of brackets for set notation. The set can be in two forms. The first form is the tabular form, and the second form is the builder's form. Now when we say tabular form, what do we mean? It's the basic form. The basic form meaning I can say A is equal to 2, 4, 6, 8. Now this form is known as the what? The tabular form. Now when we're talking about the builder's form, in the builder's form, there you will now introduce a variable. Now a variable will then take the position or the place of these elements, like summarizing it, right? Now, if you want to write this again in the builder's form, you say A is equal to, you open your bracket, X. Now X is the variable such that, now this line is translated to such that X is the even number between 1 and 9. I'm just trying to summarize this here. Now this form we are seeing right now is called the builder's form. All right, so what we're going to do, we're going to hop into our study material, MTH101 material, and take a look at the exercise that we're given. Now here we have A is equal to all this stuff. So A is a set X such that X squared is equal to 4X squared. Actually, this square is not supposed to be there. It's actually wrong. It's just supposed to be 4, not 4x squared. This is actually an error in the material. So we're supposed to just have it's equal to x such that x squared is equals to 4. Now this is supposed to be this, but for some reason they have this is not supposed to be here. It's an error. Now, from this, you find out that when we decide to solve this equation, because they say we should write it in what? The tabular form. So what we have is x squared is equal to 4. We have x is equals to square root of 4. X is equal to 2. So meaning, what values can you put into x such that x squared, if you square those values, you get 4. So if I say 2 squared, I'll have 4, right? Same also if I say minus 2 squared, I'll have 4. So with this, we can say that, we can say A, in tabular form, A is equal to minus 2, 2. Remember, minus plus 2 is the same thing as 2. When you have to do with plus, you don't have to put the sign. It's the same thing. So this is the solution for this in tabular form. But if we're going to go by what we're given in this example, it said x squared is equal to 4 squared. This automatically becomes x squared is equals to 16. So x is equals to square root of 16. X is equal to 4. So with this, we can say the two values that can go into x that you square to give you 16 is minus 4 and plus 4, right? So I can now say A is equal to minus 4 and 4. Now, the reason why I'm doing this is because I'm using this equation right now. But as I said, this 2 is not supposed to be here. So you get the first solution. But if you are leaving that 2 there, this will now be your answer. Alright, let's proceed. Let's try out the next one. It said B is a set of x such that x minus 2 is equals to 5. So what are the, say write it in what? In the tabular form. So the equation is x minus 2 is equal to 5. Remember, x, this minus 2 would have to take it over to this side. So as soon as minus 2 is crossing the equal sign, it becomes plus. So we'll say minus 2 over here is plus 2. X is equal to 7. So what value is here? So we can now say B is equal to 7. Right? Now another way of solving this equation is, you say x minus 2 is equal to 5. You add 2. To eliminate this minus 2, you add 2 to both sides. So I'll say x minus 2 plus 2 is equals to 5 plus 2. You see plus 2 here? I'm adding plus 2 to both sides. So I now have minus 2 plus 2 is equals to 0.